Okay, I'm on page 3 of your packet, and we're going to go through a couple of these parent graphs. So the first one that we're going to go over is the unit that we're on now, exponential. Exponential functions. And the parent equation here is going to be y is equal to 2 to the x. And we know it's an exponential equation because the x is in the exponent. So the next thing that we want to look at is this general equation. So we're going to have y is equal to a times b to the x minus h plus k. Now we're used to just saying a, b to the x, but there's going to be a couple factors here like h and k. You can have numbers on the outside here. Okay, and we know that 2 is our base and x is our exponent here. So if we're going to go over properties of this equation, we know that when b is greater than 1, our graph increases. And we call this growth. And when b is less than 1, our graph decreases. And we call this decay. So talking about our h comma k value, we're going to get to that a little bit later. I want to fill out my table here. So if I'm plugging in values for x, I'm just going to say -2, -1, 0, 1, and 2. Now if I'm plugging in to my equation here, if I'm plugging in -2, that means I'm going to have for y 2 to the -2. Now 2 to the -2 is it's a negative exponent, so we flip it to the other side of the fraction and the exponent becomes positive. So 1 over 2 to the +2 becomes 1 over 4. And I'm going to have 2 to the -1, so I flip that to the bottom of the fraction. It becomes 2 to the first power, which is just equal to, here now we have 1/2. 2 to the 0, anything to the 0 power is equal to 1. 2 to the first power is just 2. And 2 squared we know is 4. So I'm going to plot those points on this graph. -2 for x and 1/4. It's going to be right above the x-axis. Then we have -1 and 1/2. Sorry. We have 0 and 1. We have 1, 2, and then 2, 4. So we can see our exponential function here. So if you're confused about what the graph looks like, you can always do your xy table. So let's talk about our domain and range. So our domain is the range in x values. This arrow is pointing all the way to the right, and this arrow is pointing to the left, and there's no cutoff point there. So our domain is -infinity to infinity. Or we can say all real numbers. Now, our range has a cutoff point. Our y values never go below this x-axis. So that means the y values has to be greater than 0. Now, here's the thing. We're used to saying greater than or equal to 0, but with exponential functions, this will never actually touch the x-axis. We call this a horizontal asymptote. We have a dotted line here. The graph will never cross it. Horizontal asymptote means it's never going to cross that, so y has to be greater than that 0 mark there. Okay, let's quickly do an example with square root functions. So if I'm talking about a square root function, let's see. 1 second. Pause for suspense. Okay, so square root function, let's just say square root. And the parent equation is going to be y is equal to the square root of x. Now the general equation is going to be y is equal to a square root of x minus h plus k. And we'll talk about that in a second. As far as some properties, so we're going to talk about that here, the x-axis, we can't have any negatives under our square root. So that means we're going to have when x is equal to 0, that means we're going to start at the origin. And when y is equal to 0, we're starting at the origin. Okay, so let's go to our xy table. So I'm going to choose -2, -1, 0, 1, and 2. If I plug in a -2 for x, that means I have the square root of -2. Remember, whenever there's a negative under a square root, that's imaginary. So this would actually be I times the square root of 2, because we know -1 is I. So because this is imaginary, I can't put a point on this real plane, so we can just kind of forget about that one. Same with this one. The square root of -1, that is equal to I. So we're not going to plot an imaginary number. We can forget about that one too. That's why here, for our properties, we're starting at 0. Now, the square root of 0 is just 0. The square root of 1 is 1. And the square root of 2, well, we're not exactly sure what the square root of 2 is. We could estimate it, which is 1.414 after plugging into a calculator. So let's plot this. 0, 0. I know nothing is going to be to the left here. I'm not going to have any negative x values because it gives me imaginary numbers. So everything is going to be in the positives here. And then I have 1, 1. And then 2, 1.42. And we know the square root functions are going to make this little swoosh. And there we go. Let's talk about the domain and range. Domain is x values. So my x values, I'm talking about going from left to right, they start at 0 and they go to the right, which means they get it's greater. So the domain is x is greater than or equal to 0. Or you could write this as 0 to infinity. Same with the range. Range, we're talking about our y values. My lowest y value is right here at 0, and then they increase, so they get to larger y values. So it's going to be y is greater than or equal to 0, or you can write that as 0, infinity. The description of h, k. This h, k value will be our starting point. So where that point tells us where we're starting our swoosh. So I'm just going to say starting point. And in this example, h and k were 0, hence why I started at 0, 0. So we're going to stop there, and you guys will have another video on a couple more parent graphs.